So, good evening, everyone. And this is week 11, second last, and the live session will be from 7 to 9. So, can you please confirm whether my voice is audible to you or not?
Yes, ma'am.
Okay, you were speaking something, but I couldn't hear you, Venkateshwara. Okay, thank you so much for your response. Okay, so this is the syllabus that we will cover today. So the syllabus is solid waste management and hazardous waste management. So first, what we will cover, we will see what different type of solid waste we can have. It may be like based on the source. It may be from your kitchen. It may be from agricultural field. It may be from industry. So based on that, like how we may have a lot of classification. It may be that if we want to see whether the solid waste is degradable or not, so based on that also we can classify the solid waste. So we will classify using different ways. Then we will see what different method, how we can collect, how we can dispose, how we can transport the solid waste from one place to the another place. This we will see. Then one of the method is landfill to manage the solid waste, so we will also learn about this. Then hazardous waste and plastic waste, this is little different from the municipal waste, so we will have very few question on this hazardous waste and waste plastic management. Then the thing is, to manage the solid waste, the first thing is we can do the landfill. But landfill is not the right option because this is just that occupying the space beneath the soil, so it is not the right, it is not obviously the universal way to manage the solid waste. So what we can do is we can recover some energy through solid waste, through solid waste management. So what we can do the combustion of this solid waste so that we can first we can reduce the volume, we can remove this solid waste into a new form that can generate the energy. So we will talk about incineration because we can do the incineration of your solid waste. We will talk about the gasification and we will talk about the pyrolysis. So these are three basic topic that we will cover because these are the main topic by which we can recover some energy from the waste. And so I'm starting first with the classification and then we will end up to the paralysis. So this will be the content of your week 11. Okay, so the first part is just to know about your solid waste, what different characteristics we have in the solid waste, and how we can classify, what do you mean by landfill, how we can manage hazardous waste and plastic waste. So this is your first part, and my first part start with this one as like this is very clear, I think, based on source from where your solid is coming. So based on that you can classify that solid waste among domestic, industrial, or agricultural waste based on biodegradability, because we want to recover some energy from the waste, so we have to degrade that. Or if we want to have manure from solid waste, then this biodegradability is one of the property that we should know. So whether our solid waste is biodegradable or not biodegradable, this is another category. Then based on combustion, as I told you, we want to recover some energy, so whether that solid waste is under combustion category or not, so it may be combustible, non-combustible. Then to make the compost, what is the ability of that solid waste? So based on compost ability, it can be compostable and non-compostable. And usability, how we can use that, it is organic, we can recycle. So for example, if it is a plastic waste, I think we can recycle it. If it is some organic, so likewise we do have different categories. Now the next question will be based on the agricultural waste, and that question will see what different characteristic of that agricultural waste we have. So next question is on agricultural waste. Okay, so the question is, lignocellulosic agriculture residue are mainly composed of, and you have cellulose, hemicellulose, lignin, other, protein, fat, mineral, others, cellulose, hemicellulose, lignin, others, starch, cellulose, hemicellulose, lignin, and in which we have some percentage of how much percentage of that particular compound we have uh, in agricultural residue. So you have to tell me the percentage and what compounds we have in agricultural residue. Let's say you are harvesting wheat or you are harvesting rice, so you will have some waste. That waste, most of the time, it is burned in the farmland. But otherwise, if we are not burning it, we can use it somewhere, let's say. But we have to see the property of that agricultural waste. So, and to know the property, it is always better to see what compound it have. So what do you think? What is the right answer for this? Any guess? Okay. So Dia gave me A option. So yes. So if very simple, if you are having let's say uh, stock of rice or wheat, then it will have cellulose 38 to 50%, hemicellulose 23 to 32%, and lignin 15 to 25%. But the thing is, why we are talking about this, and what do you mean by cellulose, hemicellulose, and lignin? What is the difference between these three compound? The first thing. Second thing is, will it help us to like to burn, or if we want to create compost out of it, and to make compost of it, it should be biodegradable. So which of the compound is more biodegradable as comparison to the another compound? So we will learn about this as well. So then there is some explanation. So if we are having grass, corn stover, baggage, wood chips, so in which we may have three compound mainly, and these are hemicellulose, cellulose, and lignin, and the percentage is given in the left hand side. Now the question is, what's the difference between these three, and why we are talking about this? So if we see the cellulose, I think it is if you people have learned chemistry in your 12th standard or maybe in undergraduation, you must have known that cellulose is nothing but a linear chain of glucose unit. And if we are talking about hemicellulose, then these are the branch chain of various type of sugar, not just glucose, but it can be fructose, it can be sucrose. So branch chain of various sugar. And if it is the lignin, then this is complex aromatic polymer. So this is the first thing that you should know. What's the difference between cellulose, hemicellulose, and the lignin? The important thing is solubility as well. Solubility will define whether it is biodegradable or not. So cellulose is insoluble in water, hemicellulose partially soluble, and lignin is insoluble in water. And this you already know about this. And decomposition, cellulose slowly decomposed by cellulase enzyme. Hemicellulose can be easily hydrolyzed compared to cellulose, but lignin is high resistance to biodegradable. So we have to see how much percentage of lignin, hemicellulose, and cellulose we have in that particular agricultural waste, so that we can see whether we can use it to make the manure, let's say, or to we can recover some energy after doing the combustion. So this we can do after seeing the percentage of this cellulose, hemicellulose, and lignin. Okay, so I'm coming to. Okay, so you have seen that you have classified your solid waste according to some basic criteria, for example, source, for example, biodegradability, and all. The thing is, you have seen at your city or at your village that you have to dump your waste at somewhere, then someone will come and will transport that, will collect that, and will take it to some another place where we can do some processes, some segregation, and after that it will be decided whether your solid waste can, like what purpose we can use of, right? So but this is important, how we are handling the waste, how we are separating it, how we are storing and processing it. So a few questions are based on this collection, segregation and the transportation. Okay. So, which of the following statement correctly differentiate stationary container system? So, we have two type of containers: stationary container system and whole container system in solid waste collection. So, these are two systems by which or container vehicle, you can say, by which we collect the solid waste. And you have to tell me what's the difference between these two system: stationary container system and whole container system. I have four options here. In SCS, a container are transported directly to disposal site, where in HCS they remain at the storage location. B is in SCS, container are emptied into collection vehicle at the storage site, while in HCS, container themselves are hauled to processing or disposal site. C is both SCS and HCS involve hauling the container to disposal site, and D is in HCS, container are emptied into vehicle at storage site, while SCS container are hauled to store disposal site. So you have to know the difference between those two system. I will tell you, don't worry, but you can also have some guess about these things. Okay, so let me see the answers. Okay, I have A and D answer. Let me show you which one is the right one. So the right one is B, not A, and also not D. Yes, Dia corrected the answer. Yes, Dia. So answer is B. And let me show you. Like you may do not know that what's the difference between this. So let's see. Okay, so we do have two collection system: how we collect the garbage, how we collect the waste, right? So we have two system: a hold container system and stationary. Hold means you are pulling something from one place to, let's say, another place. So this is the container used for storage of waste, are hauled to the material recovery facility, transfer station or disposal site. So it is like we are moving the vehicle, and we are moving it to some recovery facility, transfer station or disposal. Let me see. Dia, A is the answer for previous MCQ. Let me see. Okay. Uh, First, give me the. Let me give the explanation. Then you can talk about this. Which one is the right answer? Okay. So yes, it seems like A is the right answer. So the first thing is hold means you are like pulling something and you are transferring the material from one place to the another place. Then you are emptied and returned to either their original location or some other location, and you have to empty it, right? And then you have to return. So this is kind of vehicle that have some waste, and what you are doing, you're transferring it to disposal site or to some other recovery facility, and then you are returning or you are going to the another location. Okay. Stationary, you know that stationary is stagnant at that one place, so the container remain at site. So it may be residential and commercial. Then in hold container system, so such kind of system will come under your hold container system. So crane truck, then truck with tilted frame for hold container, and hoist truck for hold container. So such things will come under your hold container system. It is ideally suitable for the removal of waste from the sources where the rate of generation is high. High generation rate, yes, one truck but require a round trips. It may be that there is just one truck, then we need to empty it, and we have to return that vehicle so that it can collect more. And the type may be hoist truck, tilt frame container, trash trailer, and it can eliminate a spillage associated with multiple small container. So this will come under your hold container system. This will also come under this hold, just giving you the example. And the convention way is that the container hold off to the disposal site, so it will collect from some site, and then it will return to the original location. So this is your conventional mode. So this is how it work. But there is also another system that is exchange container mode. Start with the empty container. So this is not very conventional way. You can read about this. Now coming to your MCQ again, because Dia told me that it may be A. So in SCS, container are transferred directly to disposal site, while in HCS they remain at the storage site. In SCS, containers are empty into. Okay, for the first question. So sorry. Let me see. This one. Yes, A is the right answer. There is a no problem in this answer. Okay, so I thought that you are saying me like you have problem with this question. So this will be your right question, right? Okay, then what are the advantage and disadvantage of housed container system? So for the housed container system, the advantage is useful when generation rate is higher and container are large. Eliminates spillage associated with multiple small container, and it is also flexible. Disadvantages: if the container are not filled, low utilization rate. Okay, so just think about some like if you are in mega cities or even in small cities, then some vehicle come and it take away your solid waste, so that will come under hauled container system, right? The next is stationary container system. So the container used to store waste remain at the point of generation, and except when moved to curb or other location to be emptied. So this will come under mechanical loaded system, mechanical loaded location vehicle. So this will come under your stationary container system. I think this is clear. What's the difference between HCS and SCS? And again, we do have some advantage. Vehicle does not travel to the disposal site until it is full, yielding higher utilization rate. So it is like you already have some place where you are dumping the garbage. So whenever the garbage area will be full, then that vehicle will go there and will take off that garbage from there. But in HCS, so in HCS it will go to the like home to home, it will go and it will collect. So it may be that it may do not have a large garbage volume, so the utilization rate may be low in that condition. And here the disadvantage is not flexible in term of picking up bulky goods. And so this is something like about HCS. Okay. In the context of waste collection system for building, You have to tell me. Low rise building usually adopt for SCS and HCS, where high rise building rely mainly on HCS. High rising building essentially use SCS and HCS system, where tenant place waste in chutes or service area. Low-rise buildings do not require any organized collection system, while high-rise buildings rely only on chutes. Both low-rise and high-rise buildings rely exclusively on curbside collection. So, what do you think? What is the right answer for this one? So we already have talked about HCS and HCS, how we can collect, how we can transport our solid waste, right? And you have to tell me which system is best for the low rise building and which system is best for the high rise building. Let me see the answer. I got D answer. I don't think that D answer is the right one. So this is answer is B actually, and let me show you. Okay, I do not have that explanation for this. Okay, so here what we have, if we do have high rise building, then we can use both HCS and HCS system, where tenant place waste in chute or service area. So like both system can work in that high rise building. So this is the right option that we have. Okay, so the next is, which of the following is incorrect about transformation in solid waste management? And you have four options here. It stabilize waste and destroy toxic element. It reduce disposal cost and aids in energy generation. It increase storage problems and handling difficulty. It improve reuse potential. Like one of the step in solid waste management is the transformation. We have to transform our solid waste, and there are some advantage of transformation. And if it is a incorrect, it means we are talking about uh, uh, that is not that will not come under the transformation, right?
B.
Okay, so Priscilla, good evening, Priscilla, and we have C answer and B answer. Uh, C answer will be the right one because this is incorrect statement. If we are doing the transformation, so transformation means either we are compressing it, right? So either we are compressing it or we are adding some chemicals into that, so that the solid waste is not a very contagious in nature. So we are doing some transformation so that we can reduce the volume, we can make it less hazardous. So this is how that will come under the transformation. So that's how it increases storage problem. No, transformation will reduce the storage problem and the handling difficulty. So this is the wrong statement. That's how C is the right answer, because the question is about the incorrect statement. Let me show you that what this transformation does. So, transformation helps to achieve efficient storage, handling, and transport. It will reduce your disposal cost, that may stabilize the waste, that may destroy your toxic element. Means you are either compressing it, you are adding some chemicals so that you have your waste that can go to the next step for the management. Electrical energy generation and reuse. So this is how we can do the transformation of your solid waste. Okay, I think very easy question. Which of the following is not commonly used as a transportation system for solid waste? Motor vehicle,
B.
railways, pneumatic system, watercrafts. Okay, so Dia gave me a D answer. I'm expecting more answers. Priscilla, Venkateshwara. Okay, Venkateshwara also gave me a D answer. Okay, so yes, D answer is the right one. Uh, we are using motor vehicle, uh, four wheeler. We also use railway and pneumatic system, but we do not use mostly the watercraft. And I was very curious when I was reading this things like what different vehicles we people use. And then I got to know something about this pneumatic system. So I haven't heard about this system, but this system is very interesting for us if because we are living in the developing country. But in developed country, like from 80s or from 90s, they people are using this pneumatic system. So let me show you what do you mean by this pneumatic system. Okay, so first just see that how we can transport the solid waste. We can use motor vehicle, for example, four wheeler. We can use uh, railways. There may be some hydraulic system and some pneumatic system and some compressed vacuum system by which we can transport. If I'm coming or if I'm focusing to the pneumatic system, so just see here they do have five system here. One is brown, blue, green, and gray and yellow. And that lady is disposing some waste into that. So this is not like what we have. Mm, we have someone mic is unmuted. Let me see whose mic is unmuted. Everyone is muted, I think. Everyone is muted except me. Anyway, so the thing is that lady is disposing some garbage into that system, and we must. We have seen we haven't seen seen actually in India such kind of system. So this is not just like that. This is not up to this one. This is not up to this one. It is not up to this one. So we have some garbage container and which have some space. Let's say it can take 15 15-meter cube space or like something. That this is not up to that place. This is something, let me show you. This is something like that. Every people, so we have, let's say, multi-story building, and in multi-story building we have such kind of installment. And in that installment people are putting that garbage into that installment, and that garbage will move. Like they do have proper drainage system for the solid waste even, and that system. And we also have some vacuum in it and some pressure system, so that pressure system will give you some pressure so that it will go somewhere, it will segregate the thing, and then it will go to some site. So this is how the well connected drainage system even for the solid waste, many solid waste, the developed country have such kind of system. So that will come under the pneumatic system.
इंडिया में भी है गिफ्ट सिटी में.
Anyway, um, so coming to, so for example, if we have solid waste, how we can dispose this? Which of the following is not a scientifically recommended method of solid waste disposal today? And we have landfilling, barging into the sea, open dumping, feeding to hogs. So what do you think? What is the right answer for this? Which one is not the scientifically recommended method of solid waste disposal today? Okay, so Dia gave me a B option. Yes, I also agree with B option. The thing is, uh, each of these system do have some disadvantages, right? So if we do have land filling, till we do not have a like proper method by which we can do the land filling, it may also have some disadvantage. But right now we do have a very modern type of land filling by which we can reduce the drainage of the toxic chemical into the groundwater. So this
There,
we can do right now. Barging into the sea, dumping your waste into once again disturbances coming. I don't know from where it is coming. Let me see somewhere. Is it still coming? Uh, I don't know like what problem we have, but everyone is muted actually. Okay. Someone is not muted, but what I can see is everyone is muted except myself. Anyway, so we were talking about the landfilling. So we do have very scientific way by which we can do the landfill. So this is we have some scientific way. So A is not the right answer. Barging into the sea, so dumping something into the sea is again not the right option, because it can affect the marine ecosystem, right? If we are like having some treatment of the solid waste before dumping into the sea, then it is okay. But like if we are dumping it as usual, then this is not the scientifically recommended method. Open dumping is also not the scientifically recommended, but the thing is, we may argue that open dumping can give you the highest degradation level, and that's how we can reduce, or we can reduce the size of your solid waste. So this is how, like, because bacteria or some different organism will work on this open dumping, because this is the area where we will have the atmosphere and oxygen presence will also be there. So some biodegradation will happen in the open dumping. But yes, this is also not the scientific recommended. But more than that, barging into sea is more not scientifically recommended. So this is like with reference to open dumping, barging into the sea is more not scientific recommended method, right? Feeding to the hogs, it is also not scientific. But if we are comparing among these four options, then B will be the right option. Okay. So till now, what we have learned is how we can like what different classification we have in the solid waste. The first thing. The second is how we can transport this. We have HCS and we have SCS system. How we can collect and we can transport the solid waste. Then based on the classification of your solid waste, we can tell what kind of treatment, what kind of management we can do of that solid waste. So for example, if it is a municipal solid waste, if we have segregated it at the source, so we can tell whether it is recyclable waste, and some portion may be organic, some may be inert debris, or some portion may be the hazardous waste. If it is a recyclable waste, we again segregate which one is non-combustible, which one is the combustible, and based on that we will have different strategy. In organic, if the solid waste have organic fraction, then it can go for the composting, vermicomposting, biogas, and landfill gas. If it is a inert debris means we can't recover the energy. We This is not the biology, like it can't undergo biological treatment. So it means we can use it for the construction. Okay, so low grade construction and paving of road can be happen with this inert debris. For example, if we are having much soil, or let's say much cement, or some another inert debris you can talk about, then if it is a hazardous waste, then if it is a coming from hospital waste, then incineration, we will talk about this. So incineration is the best option that we have. Another option we may also follow. And in India, and mostly landfilling is the mostly used for disposal of residual waste. So for example, if we have recovered, we have incinerated, and if we have recycled, t- after that also, if we have some uh, solid waste, then the last hope for us is the landfilling. Okay, because we will cover this three at length, so that's how yeah, I was planning to tell you that if we have any solid waste, so that we can convert that solid waste to generate the energy. So there may be thermochemical conversion, there may be biological conversion that we can uh, uh, under like using some microorganism, we can degrade, or we can biodegrade the solid waste. We can also have chemical conversion and physical conversion, but we will talk about this at length today. Okay, as I told you, at last, the most used option is a landfill. But we have three type of landfill: secure landfill, monomial landfill, and the sanitary landfill. And these three landfill, or three classes, are used basically for three different purpose. And so you have to see which option is the right one. Engineered for MSW, so municipal solid waste; for hazardous waste; for uniform waste like incinerator ash. So we do have three type of landfill, and this, the purpose of three type of landfill is different. Okay, so Dia gave me A answer, Priscilla A with question mark, and yes, A is the right answer. So what we are seeing, that if it is a secure landfill, then this is for the hazardous waste, right? If it is a sanitary landfill, then this is for the uniform waste like incinerator ash. And if it is the monomial landfill, then this is engineered for municipal solid waste. I have a few more things to explain you. Okay, so if we do have secured landfill, that will come under class 1, and it is for the hazardous waste. And these specially engineered and line-in facility designed to safely isolate hazardous waste from the environment. So we have to dispose it in such a way that this hazard material do not affect the microorganism, whatever we have in the soil, beneath the soil, or at the top, or in the environment. So it should be covered in such a way. So this is the secured landfill. If we are coming to the monofill or monomial, then this will come under class 2. This is specific uniform industrial waste, for example incinerator. Okay, so I gave you wrong explanation here, right? This sanitary landfill is for the MSW. So this one will give you A answer. Sanitary landfill will give you the engineered for MSW. Okay, so we were here. So if we do have monofill, then we can use mono means you have uniform, right? So that's how this will, whenever we have incinerator ash, then we will use that monofill. And sanitary, this is specifically for MSW. So this is how, please switch your answer accordingly, because mono means uniform or one layer. So one layer means after incineration we will have just the ash. So that ash we can dump into the monofill landfill. But if it is a sanitary landfill, so so municipal solid waste will come under the sanitary landfill. Please see that answer according to this explanation only. Okay, so in the landfill, we do have four biological steps, and you have to tell me the sequence of that steps: acid phase, aerobic phase, methanogenesis, steady state, aerobic, acid, methanogenesis, unsteady to steady, aerobic, methanogenic, acid, methanogenic, unsteady, methanogenesis, aerobic, acid, methanogenesis, steady. So I got A answer, I got B answer. I think the answers start with aerobic, right? First, we will have abundant of oxygen that microorganism can utilize. After that, there will be the deficit of oxygen. Then there will be anaerobic condition. So according to that, I think you can channelize your right answer. And B1 is the right one answer. Note A. Let me tell you how. So the first thing is yes, B is the right answer. First, we will have, let's say, microorganism, and microorganism will have access to the oxygen. So these microorganism will be aerobic in nature. I think next slide that will give you more explanation. Uh, First, just see the modern type of landfill. So this is landfill that we have. So we are not just dumping the solid waste in like normally into the soil, but this is how we can structure the landfill. It is, we have liner. This is very important. We have a liner. First we lie out a liner. Okay, then we are putting waste into it. Then because of some biodegradation, aerobic condition will be there, some anaerobic microbes will also be there. So it means some gases will be formed from your landfill. So that's how there is also the gas control. Then because uh, your solid waste will go under this decomposition, degradability. It can uh, it can release some wastewater or the toxic water out of this waste. Okay, that water will be collected at the bottom, and this leachate treatment system will extract this water, toxic water, out of it from that bottom, and it will be like either we can treat it or we can utilize it for some another work. But the thing is that because this water will not be able to mix with this groundwater, so this is how we are developing a advanced or in a scientific way the landfill structure. Okay, first thing was that. The second thing is because it will go under some degradation using microorganisms. So we have four steps here. So first we will have uh, waste organic fraction. So the waste will have some organic fraction. So on that organic fraction, aerobic microorganism will first act on. Okay, that will do the hydrolysis and the aerobic degradation, and this is how it will release CO2 and H2O. The first step. The second step will be anaerobic, because it is like it is covered. Then after some time, oxygen will be in deficit, will be insufficient, so anaerobic condition will develop here. So that here we will have the hydrolysis and the fermentation. So fermentation in that fermentation and all, we will have the organic acid H2, CO2, H2O, and ammonical nitrogen will also formed. Then we will have the acetogenesis, acid forming acid forming stage, where organic matter will be degraded into some acids, for example acetic acid, H2, and CO2. Then we will have the methanogenesis. So can you see, initially we had the oxygen compounds. Later on, the oxygen compound has been removed in the form of gas. Then we will have the methanogenesis. Methane forming microorganism will act on that solid waste, and this is how methane and CO2 will be formed. So these are your four step. After that, there will be oxidation again, and that we have to supply the oxygen to landfill, and that's how it can give you CO2 and all. So these are the four steps. First, uh, aerobic, and under anaerobic we will have the fermentation, acetogenesis, and the methanogenesis. So these are different steps that we have to see under this landfill. Okay. So, if we want to estimate the landfill volume of municipal solid waste, so what volume we should have for the landfill? So, it will depend on what? So, we have four equation here, and you have to tell me write one equation. And here, M total is equal to total MSWP generated. P total is total population. PREQ is population under consideration, and rho is landfill density. So, can you tell me, like, what can be the equation by which we can estimate the landfill volume of MSW? Okay, so Venkateshwara gave me A answer, but the answer is B actually. Yes, why it is B? Because it is ton, right? It is ton. So you are having some mistake, because if it is a ton, then, and if it is in kg, right? So you have to convert that ton into kgs. So that's how you have to multiply it with the 1000. Otherwise, this A and B is very similar, right? So this thing we have to see. So that's how your volume of landfill will equal to the total MSWP generated in ton, multiply by 1000, multiply by population under consideration, divide by total population, and multiply by the landfill density. And this is how we can estimate the landfill volume. Okay, which factor is not typically considered in the actual sizing of a landfill? Excess road and auxiliary facilities, reduction in landfill volume due to decomposition, increase in compaction from added lifts, increase in waste generation due to recycling. Which one is not typically considered in actual sizing of the landfill? Okay, so Dia gave me a D answer, and I also agree with D1 only, because due to recycling, the waste generation will be decrease but not increase. So this will not be considered in actual sizing of the landfill. Uh, okay, I have the list. So, while determining the actual size of the landfill, we have to include some additional factor beyond the volume of waste alone. So, for example, excess road, space is needed for road, that will lead to the movement, right? Then auxiliary facility. Land area must be allocated for facilities such as office, way bridges and all. So based on that, we also have see how much volume we need. Then the volume reduction. Over time, biological decomposition will happen, and this is how it will reduce the volume, and that will also affect the total landfill capacity. And increased compaction. So whenever we do have more layer that we will add, so that there will be compactness that will happen in the landfill. So we have to see these factor also whenever we are considering the volume of the landfill. Okay, so we talked about solid waste management, and in solid waste management, important topic is hazardous waste management. And you have to tell me which one is incorrect about hazardous waste management. So, hazardous waste may be solid, liquid, or gas. They must be treated to remove hazard trait before further processing. Flammable hazardous waste can sometimes be recycled into industrial fuel. Hazardous waste can be safely disposed in open dumps if stabilized. And you have to tell me incorrect statement about the hazardous waste management. Venkateshwara, you have to change your option. Dia gave me correct. Yes, Priscilla also gave me correct answer. So you have to tell me incorrect one, right? Yes. So D is the right answer, because even if we are stabilizing the hazardous waste, even then we can't dispose it into the open dump. So this is incorrect statement that we can dump into the open. So this is incorrect statement. Let me show you. So hazardous waste management require literally stricter control than ordinary MSWP, that is municipal solid waste. Even if it is stabilized, open dumping is never permitted. And why? It risks leaching of toxic substance into soil and groundwater. Still, some toxic chemical can be leached down to the soil. It can cause uncontrolled fire and explosion if ignitable or reactive waste is present. It violates environmental regulations also. So proper disposal is through engineered landfill. We talked about this, with barriers and liners, or through specialized treatment and recycling, not open dumping. So that's how D is the right answer, but not C. Okay. Which of the following is the most effective way of waste management according to the 5 R's hierarchy? Reuse, recycle, refuse, recover. Most effective way of waste management. This is, I think, very simple question. Dia gave me C answer. Okay. Yes, C1 is the right one answer. And why? Refusing, like to deny. For example, you have a plastic bottle, and if you are saying no, I do not need that plastic bottle, so you are not buying that. If you are not buying that, that means you are avoiding this waste management, right? You are avoiding the waste, so this is denying the things. So this is the best way how we can manage the waste. If we are not buying, if we are not purchasing the thing that have very short lifespan, and that will go under this solid waste, so refusing is the best way. So refuse is the best, most effective way of the solid waste management or waste management. After that, if we have purchased it, right, if it is not necessary, if that particular thing has a very short lifespan, then it is prefer that do not purchase it. If we do have purchase it, if we have to purchase it, then better to reuse it. Then after refuse, we will have the reuse. We can reuse it again and again. Then we will have the recycle, and we will have the recover. So this is the hierarchy. The most effective way is to uh, cancel out purchasing the things that can give you the solid waste. So let me see the best hierarchy. So the priority one is refuse. We are denying to purchase that. Then we are reduce it, reuse it, repurpose, and recycle. Refuse, as I told you, that not to consume what is not actually needed. Okay, if that is not needed, then please do not consume that. Reducing consumption is all about the virtue of conservation and notion of doing more with less. Reuse, we are reusing the something after like some changes. Then recover or repurpose. So this is the recovery of waste without any reprocessing. For example, waste oil that cannot refine for reuse in vehicle can be burned for energy recovery, so that will come under the recover. And then last is recycle. So these are the hierarchy from refuse to recycle. And I asked the most efficient one is the refuse, if we are not consuming it, right? Okay, so the next solid may be your plastic. So which statement about plastic waste management is incorrect? Refuse meaning avoiding unnecessary item like disposable straw and bags. Recover means extracting energy from waste material like used oil. Reuse means converting waste into a completely new product through reprocessing. Recycle involves reprocessing waste to make new item like bottle into bucket. So you have to told me incorrect one, which is giving you incorrect definition and explanation. Okay, so I got B answer from Priscilla and C answer from Venkateshra. Just think about this. What do you mean by refuse, recover, reuse, and recycle? Let me again show you. Refuse, reduce, reuse, recover. Recover is, or repurpose is, this is the recovery of waste without any pre-processing. Recycle will involve some type of reprocessing, right? So based on that, can you tell me which one is the right answer? Yes. So Dia gave me C answer also. So C answer is the right one because this is incorrect statement. So reuse means converting waste into completely new product through reprocessing. We are not doing the reprocessing will come under recycling, right? So reuse means we are using it again. So this is the incorrect statement. Don't worry about the wrong answer because here we are discussing, we are learning together. So this is kind of win-win situation. So it's okay if you are giving me wrong answer because I'm here to correct you. Okay, so coming to the next question, which of the following best describe primary recycling of the waste? So we have three type of recycling or even four type of recycling: primary recycling of plastic, secondary recycling, and the tertiary recycling also. So you have to make the difference between these three type of recycling, and which one is describing the primary recycling of waste, plastic, and we have four option here: conversion of polymer into fuel through chemical reaction, reintroduction of semi-clean single polymer scrap into extrusion cycle to produce similar products, mechanical processing of mixed plastic waste to produce different products, reusing plastic waste without any processing. So, which one is describing the primary recycling of waste? The longest option, most of the time, the longest option will be the right one, most of the time, because it is giving you the explanation. So, this is little hack about finding the right answer. Anyway, so you people gave me B option, and yes, I also agree with this. Reintroduction of semi-clean single polymer scrap into the extrusion cycle to produce similar product. Uh, so let me first show you the figure. If you can see here, we have primary, we have secondary recycling of the plastic, tertiary, and quaternary. Primary will go on to the secondary, and here secondary will come under secondary will have the mechanical, so that will take extrusion, injecting, modeling, drawing, shredding. This tertiary this tertiary have the chemical and thermolysis processes that will come under this tertiary, and after that tertiary we have the quaternary, and then we have the incineration. I think this is not visible, but the thing is, in secondary we have mechanical, in tertiary we have chemical, but in primary we have just the re-extrusion or the reintroduction of scrap, industrial or single polymer plastic edge, or the part of extrusion cycle in order to produce product of the similar material. So this will utilize your scrap plastic that have similar feature to the original product. So this is only feasible with the semi-clean scraps. So this will come under the primary recycling. Then secondary recycling. So as I told you, shown you in the figure, so secondary recycling will be related to what? Was related to mechanical, right? Mechanical processing. So can you tell me here? We have four option here, and product have characteristics identical to original product. Polymers are broken down into monomers for new polymerization. Separation, wasting, and preparation of waste are required to obtain usable products. Plastic waste is burnt directly for energy recovery. Okay, Priscilla gave me C with a question mark. Please be sure about C only. Yes, Dia and Venkateshra also gave me C answer. Uh, Here I showed you, right? If we have secondary, uh, then secondary is mechanical, and in then mechanical we have this extrusion, injection, modeling, drawing, and shredding. So this will come under your secondary recycling of plastic waste management. So this will be the separation, washing, and preparation of waste are required to obtain usable products. This is something that we already have shown. Okay. The third type of recycling is tertiary or chemical. You have to tell me which one is the right one. It requires semi-clean single polymer scrap and produce similar product. It involves mechanical processing only without chemical change. It chemically convert polymers into monomer or fuel or refuse. It directly reuse plastic waste without processing. Okay, so Dia and Venkatesha both gave me a C answer, and I also agree with this, that it will convert your polymer that you have into some monomer or some fuel so that we can reuse it. Okay, so we are breaking it down. So plastic have polymers, so we will convert into monomer so that we can use it for different type of manufacturing unit. So you can read about this later. Okay, so the first part is completed, right? So we talked about solid waste, we categorize this, we talked about how we can transport this, we talked about the hazardous waste management also. So classification, this system, routes, landfill, hazardous waste, and waste plastic management. We already have talked about this. Now, after collecting the waste, and if we do not need the landfilling, and if we want to generate energy out of your waste, then one of the way is to do the incineration. So right now we will talk about incineration. What do you mean by incineration? What is the mechanism? How much air is needed for the incineration? What different factors will depend on? And then we also do have different type of incinerators and environmental aspects. So this type of things we will cover under incineration. So this is our second part. Okay, so this is something about the definition. Which of the following best represent the process of incineration in waste management? And we have four options here: endothermic reaction between waste and air producing CO2, water vapor, and heat; exothermic combustion of organic waste with oxygen producing CO2, water vapor, and heat; anaerobic breakdown of waste producing methane and CO2; mechanical shredding of waste followed by reuse. What is the right option? So this is something, the definition of incineration only. Okay, so Dia and Venkateshwara and okay, Priscilla, everyone gave me a B answer only. And yes, I agree with this. So two things are important. First thing is, if we have any waste, we are giving the oxygen, we are converting it into CO2 and H2O. It means we are burning it out, right? We are burning it out, and after that some energy will be produced. That energy we can use in different industries. For example, that energy we can use to generate the electricity. We can steam, we can generate the steam using that energy, and after that we can generate the electricity. So this is the main thing. So if some energy is releasing, that means it is exothermic, it is giving you the heat. Okay, endo means it is not giving you the heat, right? Exo means it is giving you the heat. So exothermic combustion, burning out of organic waste with oxygen, that will produce CO2, water vapor, and heat. So this is the right explanation of incineration, right? So just see here, we have solid waste, municipal solid waste. We will give the air and we will burn it out. After that burning, we have filter, and that filter will clean the air, and pure CO2 and H2O will go on and will be released into the atmosphere. Ash will be collected at some bottom container, and this, for this ash we use the landfill. What type of landfill it was? Class 2. It was monofill landfill. We will monofill landfill we will use for this ash that we will have. Okay, so this is how the incineration will go on. Okay, so this is again the definition, and you know about this. So combustion is the sequence of exothermic chemical reaction between substrate and oxidant, accompanied by the production of heat and conversion of chemical species. We already have talked. We have waste, we have air, that will give you the CO2, water vapor, and the heat, and that heat we can use for the energy. Okay, Which one of the following lists the correct sequence of step in the mechanism of combustion? If we want to do the combustion, we have three steps, and you have to tell me the correct sequence of the steps. We have pyrolysis, drying, combustion of volatile gases, drying, combustion of volatile gases, pyrolysis, drying, pyrolysis and reduction, combustion of volatile gas and solid charge, combustion of volatile gas, drying and pyrolysis. So you people gave me C answer. So yes, C will be the right. So first we have to dry the solid waste. Okay, even if we do have some moisture into that, so we have to dry, otherwise combustion will not happen. So we have to dry it first. So this is the first step. Then the pyrolysis and reduction. So this is again very important to reduce the volume and to make it uh, like pyrolysis will not generate the energy. Okay, but it will convert first into solid char or volatile gas. So first we will convert that solid into into solid char and volatile gas, and then we will do the combustion of this, so it will be easier for us. So this pyrolysis and reduction is breaking down the complex solid waste first, and after that if we will do the combustion, that will give you the higher energy recovery. So these are the three steps that we follow for the combustion of solid waste. So this is, I think you have seen already. So first we will have heating and drying, then we will have the pyrolysis, and then we will have the combustion. Okay, I think it is not needed because drying means moisture is evaporated. Pyrolysis and reduction, what is the use of this? So that we can do some decomposition of organic matter in the absence of deficiency of oxygen. So that will produce volatile gas, tar, or some solid char. And this stage is very important because it is breaking down the complex material into simpler combustible component, and that's how we will use this volatile gas and solid char for the combustion. So these are the three different steps that we have to follow. Okay, which condition is necessary for complete combustion of waste? Excess fuel and limited air supply, proper fuel to air ratio, sufficient time, turbulence, temperature, only high temperature regardless of air supply lower than the stoichiometric requirement. So if you want to burn something, so what are the requirements for complete burnout the things? As I told you, longer the explanation, that option will be the right one most of the time. Okay, so Dia gave me B, Venkateshwara also B, and Priscilla also B. So yes, to burn anything, we have to see the ratio of fuel to air. So if we do have, let's say, 1 kg of organic compound to be burned out or for the combustion, so we need some oxygen, and that oxygen should not be insufficient. So for example, if we have that organic compound, it's, let's say, glucose, if it is H6, H12, O6, and then we need some oxygen, and that will convert it into CO2, let's say CO2 and water. Then we have to balance it out, how much oxygen we need. So this oxygen is need as per how much oxygen we have here, how much it will produce into this, so that we should have proper oxygen amount. Otherwise your converting into CO2 and H2O will not be completed. So we need proper fuel to air ratio. We need sufficient time. Turbulence will give you oxygen and will give you air. And then sufficient temperature we also have to achieve for the complete combustion of waste. So that's how B is the right one. Uh, this you have learned. Temperature we should have high to ignite. Time, advocate time. Turbulence for proper mixing of fuel and air so that oxygen reaches all fuel particle, that will prevent unburnt residue. And this is very important, fuel to air ratio. So if it is too little, it means if we do have less oxygen, that means it will lead to the incomplete combustion. If we have too much air, that may cause the heat loss. Okay, and that may reduce your combustion efficiency. So a proper fuel to air ratio have to be maintained to recover the energy out of your solid waste. Okay. So in incineration, the excess air ratio refers to what? Air supplied equal to stoichiometric requirement for combustion. Additional air supplied beyond the stoichiometric requirement to ensure complete burning. The oxygen present in flue gas after cooling. The air used to dilute combustion gas before release. You people already gave me a B answer. So yes, this is additional air that we have to supply beyond the stoichiometric requirement. Stoichiometric requirement, as I told you, we have glucose, we have oxygen, and that it is giving you the CO2 and H2O. If we are balancing it out and we are finding out how much oxygen we need, okay, so that will be your stoichiometric requirement. But beyond that stoichiometric requirement, we have to give additional air, okay, so that we do have complete burning. So that additional air supply will be known as excess air ratio. So I think this I already have explained. Typical excess air required for various combustion system is in the range of 5 to 50%. So most of the time, whatever stoichiometric amount of oxygen we are providing, 5 to 50% of it we are giving as excess air, depending on the fuel characteristic and the system configuration. Okay, successful combustion of solid waste depend on controlling which key factors. I think this is simple because we already have discussed about this. Time, temperature and turbulence, temperature, pressure and density, airflow pressure and turbulence, moisture, temperature and velocity. So Diya Venkateshwara both gave me A answer. Yes, we already have talked about this. If we want to burn something, Priscilla also gave me A. So if we need to burn something, the important thing is time, temperature, turbulence, and how much air we are providing to that, right? So that's how A will give you the right option. Okay. Uh, we do have staged combustion as well. And what is the main purpose of injecting primary and secondary air at different level? So if we do have staged combustion, so it means we are burning something in some stages, right? And we are injecting air, primary and secondary air at different level. And you have to tell me what is the main purpose of injecting the air at different levels. So to increase excess air beyond 2 for complete combustion, to improve mixing, reduce pollutant and enhance combustion efficiency at low excess air, to cool down the combustion chamber and prevent burnout, to supply air only to the upper chamber for partial oxidation. Let me see the answers. Venkateshwara gave me a B answer. And yes, I also agree with this B. Uh, yes, Priscilla also gave me B. So the thing is that we talk about stoichiometric oxygen, right? How much oxygen is needed according to the equation. Okay, we talked about excess oxygen. So excess oxygen is beyond stoichiometric oxygen. We are providing some oxygen, but we also have learned that whenever we are giving this excess oxygen, it can reduce the energy, or it can reduce the heat recovery process, right? So what we have to do is we need to reduce the excess oxygen in such a way that there should be complete combustion, but we are not giving the excess oxygen. So that's how we are having combustion in two steps. So we are injecting air in two stage, so primary and secondary air at different level, so that we can increase the combustion efficiency, we can reduce the pollutant, because we are doing the complete combustion at low excess air. Because if we are increasing the oxygen, then that means it will reduce the heat recovery. Okay, so that's how we have to balance out this uh, uh, excess air, right? So that's how B is the right answer. This I already have explained to you. Okay. In incineration, shredding is also important. And why it is important for us? And we have four options here: mass burning incineration to aid crane operation, fluidized bad incineration to ensure uniform combustion, reducing air ash formation in all type of incinerator, increasing the moisture content of waste. Priscilla and Venkatesha both gave me B answer, and yes, they also gave me B. So yes, B is the right answer. So the thing is, for example, if you have this much, this is the size of, let's say, your solid waste, and you want to burn it. Okay, so it we can't have the complete uniform combustion. If we do have like small pieces of some product, then the combustion will be easier for us, right? So to ensure uniform combustion in fluidized bad incineration, we will talk about this. We do have different type of incinerator, and one type is fluidized bad incineration. We will talk about it, what it is, and that's how it will ensure the uniform combustion. So B is the right answer. Just see about this. This is known as FBI. So this FBI is the waste combustion technology in which solid waste is burned in a bed of hot granule material. Mostly it is sand or limestone that behave like the boiling fluid when air is blown through it from below. So what it is like, at the below we have the air, but on that we have some bed of hot and it may be of sand and limestone, and from here we will have some solid waste, and that's how it will do the combustion, and it will convert into CO2 and H2O, right? So here if we are having the bed of hot granule material, so that will act like it is a boiling fluid, because air will come from the down so this is how it will behave like we do have the boiling fluid, right? So this is fluidized bed incinerator. So here you can also see, so we have burner here, we have sand bed, and we are giving air to this one, and we have this is the slurry or the sludge, a mixing tank. So this is waste we have, and these are important. Just see that before mixing this sludge into this incinerator, we are we are having pre-processing, and this pre-processing is homogenization and preheating, and then we are putting this waste into this fluidized bed incinerator, and then it will give you heat, and that's how we can use some boiler, and we can generate the electricity and all, right? So this is the next step but important is this one only. This I already have explained. Okay, as I told you, for fluidized bad incinerator, we should have pre-processing, right? And in pre-processing, we have one step, that is sorting. We have to sort out the things. Then we have homogenization, as I told you. We have to uh, we have to mix everything so that everything can be homogeneous or uniform in nature. And then we have to do the shredding. So shredding can be used when there is a large quantity of bulking waste. So homogenization and shredding we have to do before fluidized bad incinerator, right? Okay. In an incinerator, which statement correctly describes a refractory unit used for heat recovery? The boiler is placed inside the furnace to absorb heat directly from the burning waste. The boiler is located after the combustion chamber where hot gas generates steam. The boiler is positioned above the grate to recover heat from bottom ash. The boiler is used only for preheating combustion air. So I have Priscilla with B with question mark and Venkateshwara B. Okay, so yes is the right answer. So this is boiler is located after the combustion chamber where hot gas generates steam. So this will explain your refractory unit that we will use for the heat recovery. Okay, so we have different type of incinerator, and you have to tell me which one is not the common type of incinerator that we use for solid waste combustion. Fixed bad combustion, rotatory kiln, fluidized bad combustion, and catalytic converter. Okay, so Diya and Venkateshwara both gave me a D answer. Yes, I also agree with this one because these are three different popular incinerator type. Fixed bad combustion, rotatory kiln, and fluidized bad combustion. But this catalytic converter is not the type of incinerator. Okay, this is what we use in the vehicle. You can read about this, but this is not the type of incinerator. Okay, so the thing is, what is the difference between fixed bad combustion, rotatory kiln, and fluidized bad combustion? So we have a few explanation here. So just see here, if we have fixed bad combustion, so waste burn on the stationary grate or bad, air is supplied from the below. In rotating, we have slowly rotating cylindrical kiln, burn waste as it moves through. And fluidized, we already have discussed, waste will burn while suspended in a hot fluidized bed of sand or inert material. Okay, so here we do have fluidized bed that is made up of sand and all. Here we do have very stationary bed, and here we do have rotatory kiln. Okay, so that's how it will move through. Then temperature range is different. For fixed bed combustion, it is 800 to 1000. For rotatory, it may be 900 to 1200, and for fluidized bed, it is 750 to 900. If we are talking about mixing efficiency, so mixing efficiency is poor to moderated because there is a bad structure. Here we do have good mixing due to rotation, and here we do have excellent uniform temperature and contact between air and waste. Then uh, uh, how we can use this? So the suitability, what type of waste we need. If we do have dry, homogeneous, high calorific waste, then fluidized bad combustion is the good one. If we do have solid, semi-solid, or sludge waste, and even hazardous, then we should go with the rotatory kiln combustion. If we do have wide variety of municipal solid waste, sludge, low calorific, and moist waste, then we should go with the fluidized bad combustion, right? And we do have different combustion efficiency based on how much calorific value we have, how much oxygen and temperature is maintaining at each of these incinerators. So the next question will be based on how we will differentiate these three type of combustion or incinerators. Uh, okay, we do have some advantage and disadvantage also. You can read about it later. Okay. Uh, in fixed bad combustion, waste burns on a grate as air passes upward through it, while suspended in solid sandbag in a rotating steel cylinder using only liquid fuel injection. I already have I already have shown you the difference between fixed bed, rotatory, and fluidized. Okay, Venkateshwara gave me a answer, and yes, I also agree with this. So this is we have just a fixed bed, and on the fixed bed we will have the waste, and from like we will also have some air that will pass through it. Okay, so this is your fixed bed. This while suspended in a hot sand bed, this will come under fluidized. Rotating one will come under your rotatory. Used only fluid fuel injection, this will again come under your fluidized bed. So this is the one that will come under the fixed bed combustion. So you can see here how it works. So we have here, this is your ceramic plate. So this is your stationary bed. This is your stationary bed, right? And then we will have a fuel bed. So this is your waste. You are maintaining temperature, you are maintaining the air, and you are doing the combustion, and some gas will be released. So this is fluidized, sorry, fixed bed combustion. Okay, next was the rotatory kiln incinerator, and it operates by fluidized sand or limestone for waste burning, rotating a refracted lined cylinder for uniform combustion, burning waste on a fixed grate, spraying fuel into a combustion chamber. I think option itself is giving you the explanation. So yes, B answer is the right one. Yes. So this is, we do have rotating refractory lined cylinder for uniform combustion. So here you can see this one is the rotating kiln. This one is the rotating kiln, and this is how we can burn it, burn the solid waste into this rotatory kiln incinerator. Okay. Which type of incinerator does waste burn while suspended and mixed with heated inert particle by upward blowing air? Moving grate type, rotatory kiln type, fluidized bed type, cyclone furnace type. While suspended and mixed with heated inert particle by upward blowing air. We already have learned about this rotatory. Rotatory do not have this one, this explanation. Dia gave me C. Uh, No, the explanation is giving you the C answer. We have just three type of incinerator, right? Fixed bed, we already have discussed. We have fixed bed of ceramic. We have then a rotatory kiln, where we use the cylindrical, where it is rotating, and fluidized, where we do have the bed of sand or limestone, and that is giving you the it is behaving like it is the fluid, because the air is coming from the down. So this is giving you the right explanation. C1 is the right one. Let me show you here. So fluidized bad combustion use silica, sand, limestone, dolomite, or another non-combustible material for the bad material. So here we are using then which operate at the temperature of 700 to 1000. It depends on blowing air velocity. Fluidized bad system can also be further divided into bubbling and circulating. Okay. So, what is the advantage of using the fluidized bad combustion over fixed bad combustion? As I told you, the difference between these three, but I think now you can tell. Works well with moist fuel, need higher furnace temperature, give higher combustion efficiency, limited to small installation. Mhm. Dia gave me A answer. Venkateshwara B. Okay. So the thing is, I agree with A answer only, because whenever we do have moist, whenever in your solid waste we have some moisture, then we can't use fixed bad system. We have to use fluidized bad combustion. So it work well with the moist fuel. Let me show you again. Here we were like these are three differences between fixed bed combustion, rotatory kiln, and fluidized bed. And suitability, just see the waste type suitability. When we have dry, homogeneous, high calorific waste, then we will use fixed bed combustion. If we have a rotatory, then it is suitable for solid, semi-solid, and sludge waste. But for fluidized, we can handle wide variety of municipal solid waste, sludge, low calorific, and even moist waste. We can do the combustion of moist waste as well, that have some moisture. Otherwise, moisture waste will not catch the fire and will not come under the combustion, right? But this fluidized bad combustion can also take that moist fuel also. So that's how A answer is the right one. Okay, so this is again what different advantages we have. So it is suitable for high moisture fuel or low grade fuel. The typical operation temperature are lower than a mixed bed system. Higher combustion efficiency, and we will have the more suitable for large scale operations. Which condition help reducing falling or slagging in furnace boiler system for solid waste? Because it can give you some falling smell, right? It can have the slagging. So what condition can help you to reduce that smell that we will have from the solid waste combustion? What we can do to reduce that falling smell that we will have? Okay, so Dia and Priscilla gave me B option. So yes, if we are keeping the combustion temperature below 900 degrees Celsius, then we can reduce the falling and slagging. The slagging index used to rate solid fuel for falling potential is based on. So if we do have different type of solid waste, we can rate that solid waste based on what falling potential it has. And we have some index by which we can assess this potential, and this index is known as the slagging index. Okay, so everyone gave me a B answer, and this is how much percentage of alkali oxidized we have per unit energy of fuel. Based on that, we can calculate the slugging index. So this is slugging index, developed by the coal industry, has been used to rate solid fuel for fueling. This index corresponding to the mass of alkali metal as oxide per energy unit in the fuel, and is useful for rating biomass feedback too. And this is how we can calculate this. I have given you the formula. So we have four things here: popular, pine, switchgrass, and non. You have to tell me which fuel have the highest risk of slugging based on its slugging index. Popular, pine, switchgrass, and none all have low slugging risk. Yes, higher slugging risk we will have, right? So based on that, C is the right answer, right? Because it has the highest value, 0.85. Higher the value, higher the risk of slugging. Okay. So solid waste part is done, in which how we can recover the energy. One part was the incineration, and that part is also done. Then next part is the gasification. So if we do have solid waste, and if we are giving very limited supply of oxygen for the combustion to that particular solid waste, then that will come under the gasification. Some gases will be produced, and that gases can be utilized for some other purposes. Okay. So, and as we have seen in the incineration, we have to give the excess air. But what if we do not have excess air, or what if we do not have, if we do not want to give that much air for the combustion? So that will come under the gasification. So we have few MCQs on gasification right now. So very simple question: gasification mainly produces ash, sink gas, char, slag. So what is the product of gasification? Diya and Venkateshwara gave me B answer. So yes, so the product of gasification will be syngas. So, but what do you mean by gasification? So just see that it is a thermochemical process that converts carbon-based material into combustible gas mixture called syngas. Syngas is the synthetic gas. By reacting the material with controlled amount of oxygen and or steam at high temperature. Here we are giving the more temperature. Unlike combustion, gasification use limited oxygen, so the material does not burn completely. It partially oxidizes. So this is the difference between gasification and incineration. And syngas is the synthetic gas, is the gas mixture produced by gasification, which mainly composed of CO, that is carbon monoxide, hydrogen, and small amount of CO2, methane, nitrogen, and another gases. Okay, so what is the use of this? Why we are using why we are using gasification over incineration, let's say? So this sink gas, that is the product of gasification, can be used as a fuel for electricity generation. It can be feedstock for producing methanol, ammonia, hydrogen, synthetic fuel, and industrial heating. We can also have using that sink gas. So the advantage of gasification is it convert waste into useful energy and chemical feedstock. So it is creating fuel, another fuel that can give you more energy. Lower emission compared to direct combustion. It can handle diverse feedstock, and it reduce landfill waste and recover energy efficiently. Okay. Again, we need some ratio of oxygen in gasification. When oxygen and coal ratio is greater than 2.5, the main process is what? Gasification, pyrolysis, combustion, hydrogenasis. Diya and Venkateshwara both gave me C answer. Yes. So if we have that ratio more than 2.5, that means that will come under combustion. So here you can see this table. If your ratio R is more than 2.5, it means it is combustion. You have more oxygen as comparison to the coal, right? If your R is range between 0.68 to 2.5, it means you have limited oxygen, and that process will be the conversion process will be gasification. And here you will have CO and H2O. That means it is producing the syngas. If you have R less than 0.68, it means we are giving very low oxygen, and this will come under pyrolysis. And here C content decrease with R. So C is your carbon compound, right? So I think this one you can tell based on that table only. So if you have oxygen call ratio below 0.68, which process dominates? I think this one you can tell very easily. So Diya and Venkateshwara both gave me B answer. And yes, this will come under pyrolysis. Okay. Which gas has a higher heating value? Syngas, producer gas, both equal, depend on pressure. And you have learned that what do you mean by syngas, but the thing is, what do you mean by producer gas as well? Let me see what you have given me. Um, okay, so I got B answer and then B, D, A. Okay. So I'm getting variety of answers. And which gas have the higher heating value? Syngas is CO and H2, right? Carbon monoxide and hydrogen. Producer gas. Producer gas has also some amount of CO, but along with that, it also have some another gases. And based on that, heating value will be decided. And if we see which gas, obviously one gas will have higher. So syngas has the higher heating value. Let me show you. So if we do have syngas and producer gas, so first see what's the difference between these two. Syngas have H2, that is 20 to 30%, but in producer gas it is 13 to 19%. CO, it is 40 to 60% in syngas, but in producer gas it is 18 to 22. And heavier hydrocarbon and nitrogen are more in producer gas as comparison to the syngas. So it means we have the presence of heavier hydrocarbons and nitrogen and uh, water vapor at some limit in the producer gas, and we do not have much quantity in the syngas. And that's how typical heating value will be more for the syngas, that is 9.3 to 14.9 megajoule per meter cube, but it is lower as comparison to the syngas in the producer gas. So this is 4.5 to 6 mg per uh, meter cube. Okay. During gasification, char gasification mainly produce what? CO and H2, CO2 and CH4, N2 and CO2, H2O and C2H6. Char gasification. If we have char is produced by pyrolysis in the absence of oxygen. If we do have char and if we are giving the limited oxygen to the char, then what will be the main product? So I'm having A answer from Dia. Venkateshwara gave me D answer, but I agree with A only. So this is uh, yes, A is the right one. So this is carbon monoxide and H2 will be the main product of the char gasification, but not H2O and C2H6. Okay, so the next question is in gasification, volatilized gases. We have four options: burn completely, escape unburned due to limited oxygen, condense into tar, form only ash. uh, as in incineration, we got to know that if we do have volatile gas, that volatile gas can be converted into CO2 and H2O. But here we do have some limitation in gasification, and this limitation is if we do have volatile gas, that volatile gas will not be burnt completely. That will escape unburnt due to limited oxygen, and this is the disadvantage of gasification. So B answer is the right one. Yes. So these are the different steps that we have to have in incineration. So for example, drying, devolatilization, oxidation, ash cooling, and just read the bulletin point. Unlike incineration, in case of gasification, the volatile gas do not get burned. Okay. So this is the disadvantage of the gasification. Then, as I told you, the output of gasification is syngas. So, syngas output mainly depend on what? We have air and feed rate, reactor pressure, ash content, cooling water flow. So, depend on what? Venkateshwara and Dia both gave me A answer, and yes, uh, I agree with this. Priscilla also gave me a. So yes, because main thing is how much feed rate we have, how much we are giving the substrate, and then how much air we are producing, right? So based on that only, the syngas output will be dependent on. Okay, the ratio of atom in the product gas to those originally supplied define which yield parameter in gasification. Carbon yield, hydrogen yield, oxygen yield, nitrogen yield. So how much atom in the product gas divide by originally supplied define which yield parameter in gasification. Venkateshwara gave me A. I don't think that A is the right answer. You can switch to different answer. Okay, so Dia gave me B, Venkateshwara C. No, Venkateshwara. This is B answer is the right one. Let me show you. So, firstly, hydrogen yield is the right option, and let me show you. So just see that hydrogen yield, H2 yield. So this is hydrogen atom in the syngas. So this is the product. In product, how much atom you are having of the hydrogen, divide by hydrogen atom injected. So hydrogen atom we had initially, originally. So that's how this will give you the uh, this will give you the H2 yield, right? And let me see here. So the ratio of atom in the product gas to those originally supplied define which yield parameter in gasification. So this will be the hydrogen yield, right? Okay. So the efficiency of combined cycle gas turbine power plant is typically about 20%, 40%, 60%, and 80%. So what is that? So we have some power plant, and if we are having the combined cycle, if we are having the gasification in that, and by gasification we are generating the energy, and then using that energy we are producing the steam, and with that steam we also generating the energy. So this is the combined cycle gas turbine, and that's how it will increase the efficiency, right? So let me see. You people gave me C and D answer, and this will be 60% efficiency, right? So which of the following does not directly influence the gasification process? Type of feed injection, gasifying agent used, ambient humidity outside the reactor, heating method applied. Which will not directly influence the gasification process? So I got C, yes, because everything is like based on the gasification process only, type of feed injection, agent use, heating method supply, but ambient humidity outside the reactor is of no use. So this will not directly influence. So you can read about this explanation. The main purpose of Syngas cleanup. So we have to clean up the sink gas. So the product of gasification was sink gas, but we have to clean up that. And what is the purpose of cleaning up the sink gas? Increase nitrogen content, remove corrosive and toxic impurity, raise temperature, gas temperature for power generation, convert CO to CO2 for combustion. Priscilla, not C, but B. The thing is, whenever we are having the gasification, it may or may not be possible that along with CO and H2, that is carbon monoxide and H2, we may have some another gases will be released after the gasification. And if we are using COH2 along with that gases can have the corrosive and toxic uh, properties, right? So if we are using that thing, that syngas somewhere, so it can do the corrosion, so we need to remove that particular gases. Okay, so this is something known as the cleanup. So we are removing some impurities from the syngas. So that's how B answer will be the right one. So just see here, we have gasifier and we have stage 1 where we will clean up the syngas, and we also have the stage 2, here we will also clean up the syngas. After, which of the following is not a type of fixed bed gasifier? So within gasification we use gasifiers, and we have different type of gasifier as like the incinerators, right? So we have fixed bed gasifier, and we do have within that we have a lot of types within that. So okay, I got C answer. So yes, uh, which is not a type of fixed bed. So updraft and downdraft is the type of fixed gas bed gasifier, but entrained bed is different type of gasifier, right? So we have fixed bed, we have two categories, and fluidized, we have three categories, and we have entrained bed and the plasma gasifier. So these are different type of gasifiers we use for the gasification. These are the differences. You can learn about this later. Okay. Then in the fixed bed gasifier, the flow between biomass and air, and it is counter current. So how the flow of the air mass and biomass is going on. So this will be in counter current. Yes. So B is the right option. Which of the following feedback is most suitable for the downdraft gasifier? So if we do have dense, very low moisture wood chips, then we can use downdraft gasifier. Yes, so C is the right answer. Entrant flow gasifier operate best with when you have fine and dry feed at high temperature. Then we also have plasma gasifier, and this plasma gasifier, the key feature is it has high temperature plasma torch that can break down the complex waste. In plasma gasification, this plasma arc that is formed by electron ionization. Okay, so gasification is done, incineration is done, solid waste is done. The next is pyrolysis. I think I have 3 or 4 question on pyrolysis. So pyrolysis occur in the absence of oxygen, right? So D answer is the right one. Here you can see the explanation. uh, which pyrolysis process mainly produce liquid product, and this is fast pyrolysis. We do have different type of pyrolysis: slow pyrolysis and fast pyrolysis. It is based on what temperature range we are giving, heating rate we have, and the residence time. So the fast rate is giving you the liquid and gas main product. uh, uh, the one of the product of pyrolysis is the bio oil, and it has dark color, and this dark color is due to microcarbon and chemical composition. You can read here about the pyrolysis bio oil, what kind of appearance it has, odor it may have, density, viscosity, and heating value. The bio oil will have different properties, right, along with the reason. Then pyrolysis bio oil has low heating value than fossil fuel because of its high oxygen content. As I told you, whenever we will have high oxygen content, then less heat will be produced. Then we have complex composition of pyrolysis bio oil that is mainly result from degradation of cellulose, hemicellulose, and lignin. We do have low pH of bio oil, and that is because of the presence of carboxylic acid. You can read about this. The main goal of bio oil upgrading is to remove oxygenated compound. We have some catalysts that we can use in catalytic pyrolysis, and that catalyst is zeolite. And some chemical also we can use for chemical activation of pyrochar, and that is zinc chloride. And this is the last question. Pyrolysis of some plastic, PE and PP plastic, mainly produce liquid and gaseous hydrocarbons. So this was all about pyrolysis. Thank you so much. Thank you so much for showing the patience. This one was the last class. One more class we have next Monday, 7 to 9. And thank you so much. If you have any query or suggestion, you can let me know. Otherwise, this is the dinner time and you must be hungry. So please go for the dinner and have a good night. Thank you. Thank you so much for the patience. Thank you, Dia. Thank you, Venkateshwara. Good night. Thank you, Priscilla. Thank you so much.